I'm Trent Scott from the Tennessee Electric Co-op Association in Nashville. Welcome to Along Those Lines.
NRECA's Along Those Lines podcast is supported by Power & Tell, a company that specializes in the procurement, sales, and material management of communications products. Power & Tell's supply chain expertise provides electrical co-ops and contractors with a cost-effective and reliable way to get the material they need for their network construction and maintenance.
Hi, everyone. This is a podcast about electric cooperatives, the work they do, and the challenges they face. I'm your host, Scott Hoffman. The number of electric utilities deploying large battery systems to store power is on the rise, but it's a technology that's still very much in its infancy. How are electric cooperatives integrating storage, and how are they using it to serve their members? We'll talk to NRECA's Jan Ahlen, who will help us understand how this promising technology works and where the trend is heading. But first, Anza Electric Cooperative, based in Southern California, is getting ready to deploy its first utility-scale battery storage unit to help battle resiliency challenges they face due to the region's frequent wildfires. We caught up with Anza's general manager, Kevin Short, at a recent conference. Kevin, welcome to the podcast.
Thanks, Scott. It's good to be here.
Tell us a little bit about your membership. You're a relatively small co, about 7,000 meters, is that right?
A little more than 5,000, actually, yeah. Mostly residential, virtually 92% residential load. Very small little town, the usual amenities, a little grocery store, gas stations, a couple of restaurants, that type of thing.
Mm-hmm. Give us some of the details about what exactly it is you're installing. I know it's a battery project, and I know it's meant to be kind of a microgridding scenario. Talk about some of the details.
So the first phase of the project was just a straight 2 megawatt photovoltaic array. Turns on when the sun comes up, turns off when the sun goes down. Just simply to help us meet our renewable goals and some on-system generation. So the second phase is another 1.4 megawatts of PV, which also includes a 2 megawatt battery, 2 megawatt, 4 megawatt hour battery. So the concept here is that we can utilize this battery in an outage situation and parallel all of the solar generation along with that to help us provide some capability, some resources for our service territory during an outage.
You alluded to some of the difficulties you've had with reliability and outages. Kind of set the scene for us. What makes your system unique in that particular regard?
Well, we're fed from a single line out of a Southern California Edison substation, and that line runs through U.S. Forest Service territory. It's subject to wildfire issues and a variety of other outages. So in recent years, we've had quite a few outages that have taken us down for anywhere from a few minutes to one major outage during 2018 that took us down for 10 days. So that's been one of our biggest barriers to reliability is the fact that we don't have a backup.
So as far as the battery project, what are you forecasting in terms of when it's going to be ready? And then talk a little bit about how you're going to use it once it's online.
Okay. We already have the solar modules for the project. They're not on site. They're in storage right now. We're waiting for the battery manufacturer to be chosen, actually, and the microgrid controller. We're waiting on that as well. We anticipate that should be and running by the middle of the year. And the plan for it is to keep the batteries as full as possible via the solar. That's actually a tax requirement. 75% of the energy has to come from a renewable resource.
Right.
And those batteries will be ready for any kind of outage that we can foresee, and operate that in an islanded mode, which means that it'll simply be off grid. And we're aiming to utilize that for the circuit that runs through that little downtown area we have and try to keep those services up and running for our members.
Okay. Would you be able to keep your entire system running with the battery, or would you have to kind of pick certain resources that get power?
Yeah, it's not big enough to handle a whole system.
Okay.
It's one circuit at a time right now. We're thinking and looking forward to the possibility of deploying more batteries in the future and having more capability for actual off-grid operation of multiple circuits at a time.
Yeah. Are you working with anyone with the planning and help with the siting and things like that?
Our G&T over in Arizona has been just absolutely phenomenal in helping us get this thing set up.
That's great. And talk a little bit more about the G&T aspect of this. The need was obvious. How did that conversation go?
Well, it's been a long-term conversation, really, because we are an all-requirements member of the G&T. That essentially means that whatever we need from an energy standpoint, reliability standpoint, transmission assets, everything basically needs to come from them. And so we've negotiated over several years over these requirements. Being the only California member of an Arizona G&T has presented some challenges for them.
Right.
Because they've had to really think about what it is that we're doing here and what the state requirements are as far as resources from renewable sources going. Being a California utility, we have renewable requirements that we're expected to comply with, and greenhouse gas reduction issues that we have to pay attention to. And so AEPCO has been very, very helpful in that regard.
Yeah. The situation of your co-op is fairly unique. But is there anything that you can talk about in your experience with working with the G&T, with making the decision on doing storage and creating this sort of microgridding capability that would be useful to other co-ops, things that you might consider going into such a project?
Well, I would certainly advise anybody that's in a similar situation to take a look at all of the options. One of the things that we did several years back was a source review of all of our available options to address this problem, and that was again with the help of our G&T. And we looked at maybe a dozen different options, and virtually none of them except one even panned out as being feasible. And on further inspection of that additional transmission line that we looked at, it turned out to be, at first estimate, a cost of more money than our entire system's value, wow, which made financing kind of a challenge, as you might imagine. So ultimately, we came down to, with the renewable mandates combined with the resiliency issues and reliability issues that we had, we felt that this battery storage solar option was one of the best ways forward.
Did this project come about at all through conversations with the membership? Is the membership aware of what you're doing? Are they supportive of it?
Absolutely, yeah. We've talked about, during our regular annual meetings with our members and other communications, we've talked about this issue over the last couple of years with our members, and they're very supportive of the concepts of improved reliability plus increasing a renewable resource. So we've had a lot of support from them.
Kevin, thanks so much for being on the program. Do come back and talk to us at some point about how the project's going.
Absolutely. Looking forward to it.
Right, thanks, Kevin.
Thank you.
Barry Brown is Executive Director of Engineering and Transmission Maintenance at Anza's G&T, AEPCO. He talked about the unique approach they took with Anza to get the project off the ground. Barry, thanks so much for being on the program.
It's good to be here.
Okay, so you have had a relationship with Anza for a while. I know they're in sort of a unique situation, being in California, you're generating out of Arizona, and you're basically their only transmission line into their system. Can you talk a little bit about that situation and give us kind of a lay of the land?
Yeah, certainly. We distribute power and energy to them through the market hub at, I believe, at Meade. And from there, Cal ISO takes that energy and provides it to them through Southern Cal Edison. And SCE owns and maintains the only transmission line up to their distribution co-op. So it's a 25-mile line, and it's the only line that serves them. It's a 33 kV line.
Okay. And the latest, or one of the latest, is them deploying or working on deploying a battery backup system or an energy storage system. Talk a little bit about the specifications of that project. How is AEPCO involved, and where is that in kind of the status of the project?
Okay, so Kevin probably talked about our relationship with NRECA and DOE via Sandia National Laboratories, which we began discussions with Sandia and their experience with microgrids and battery storage in the spring of 2018. So they helped us do a number of different studies and found out that one of the best justifications for providing battery storage at Anza is potential to defer significant increased transmission costs by bringing another transmission line to serve Anza. So we worked with them a good probably 8 or 9 months or maybe 10 months, and then we began writing a spec. AEPCO actually wrote the specification for their phase 1, and since we're the all requirements serve G&T for Anza, we put a specification together and bid and then constructed their phase 1 solar back in 2017, I believe. So we did that same process. We took the specification that we generated in that first phase. NRECA had a consultant who really did a major portion of the work on the microgrid part of the specification. We did the solar and the battery. And so we put that all together, created a bidder's list of people that we felt were very capable at doing microgrid and battery energy storage.
Okay, and so give us a sense of what size, what's the capacity of the battery storage unit, and what is AEPCO's involvement in the deployment of the actual stored energy?
So AEPCO is working as essentially the project manager. So we are working with the contractor, with a third-party financing firm, to assemble a project that is ITC capable, so we can take advantage of the investment tax credit.
And we talked to Kevin a little bit about how they're going to use this, but from your perspective as the G&T, how do you see this unit being deployed, and how does it help with some of the problems they've been having?
So what we're trying to do is we've looked at Anza's load forecast. Our dispatch center, which operates out of Benson, Arizona, will work closely with Anza to make sure the microgrid program works as it's designed and take advantage of it when they have short outages. And that way we can take certain circuits out of service at Anza and still keep essential services hot, and then wait for the system to come back in line, and we will re-energize Anza's system and sync to the grid.
Okay. And just for our listeners who may not understand how these work, this size battery is not going to run Anza's whole system. It's going to be designed to run some critical infrastructure. Is that correct?
That's correct. I think their load today is somewhere around 15 megawatts at peak, and so it's 19 megawatt capacity. This is nowhere near that, but it's an opportunity for Anza to get involved with battery storage, to have it useful. And then the other primary purpose is that as we get closer to the late 2020s, there will be periods during peak where for an hour or 2 hours we will get into that 19 megawatts that can't be provided by the transmission system, so the battery will pick up in those periods as well.
And in terms of the broader idea of how G&Ts and distribution co-ops can work together, I mean, storage is only going to get more prevalent in the grid. How do you see this as kind of a test case for how G&Ts can work with their distribution co-ops in getting these things done?
Well, I think, we can certainly serve as an example to those that haven't developed battery yet. And Kevin will certainly speak for its effectiveness, and, we'll just work together. We enjoy serving Anza. They're a vital part of what we do as one of our key distribution co-ops. We want to be able to help serve all of them. As you say, battery storage becomes more prevalent.
Great. Barry, thanks so much for being on the podcast.
It's our pleasure.
Up next, we'll learn about the basics of battery technology and hear how battery storage is growing across cooperatives. But first, a word from our sponsor.
Support for Along Those Lines comes from Power and Tel, presenting this message. Whether you're maintaining fiber networks or exploring deployment, Power and Tel has the products that members need when and where they need them. Power and Tel believes they go the extra mile to match the right product and solution to your specific needs. Let Power and Tel's value-added services simplify your network deployments. Visit ptsupply.com to learn more.
I'm Marion McLemore from Flint Energies in Warner Robins, Georgia. You're listening to Along Those Lines.
Welcome back. Jan Ahlen is with NRECA's Business and Technology Strategies Group, and one of his areas of expertise is working with co-ops across the country to share information and best practices in battery development. Jan, welcome.
Thanks for having me.
Okay, so large battery storage systems, do they behave the same way as the battery systems in your devices work, or is there something different about them? How do they actually work?
Yeah, pretty much. So one thing I would say is that when we talk about battery storage systems, it's basically the same chemistry as anything that's in your smartphone, your tablet, or an electric vehicle. And we're primarily talking here about lithium-ion batteries. So the vast majority of batteries have been installed at the utility scale over the past several years have been lithium-ion systems. And the basic idea is pretty simple. The systems, they charge from the grid or from a co-located solar device, for instance, stores that energy for a period of time and then releases that energy onto the grid at another time during the day.
Okay. One of the things I've noticed when you see writing about one of these systems, it's always described in terms of kilowatts and kilowatt hours or megawatts and megawatt hours. Explain a little bit about how that works.
Yeah, so that's something that a lot of people get tripped up on. So kilowatt hours is basically the amount of energy that's within the battery system. Kilowatts is how much energy can be released at any one given instance. So a pretty easy way to understand the difference between kilowatts and kilowatt hours is to think of the battery system as a water jug with a spout. So size of the tank is essentially analogous to energy, amount of gallons that's in the tank.
And that's the kilowatt or megawatt?
That's the megawatt hours.
Okay.
And then the megawatts, that's the size of the spout. So that's the flow rate, of the amount of water that can actually be released at any one given instance.
Okay. And so you mentioned earlier that the co-locating solar and ways that co-ops are using their infrastructure to charge these batteries. Talk a little bit more about how co-ops are not only charging them, but dispatching them when they need them. And as a side to that, how many co-ops are actually using storage systems at the moment? It can't be that many.
Right. So I think we're just scratching the surface on a number of co-ops that are actually using energy storage systems right now. We are getting pretty close to about 20 states where there are co-ops that are integrating storage into their systems. But, the great thing about batteries is how flexible they are. You can use batteries for a number of different things. So a number of those use cases would be integrating renewables, managing their demand or peak reduction, improving their resiliency, building out microgrids. And then finally, a very interesting use case would be deferring pretty expensive infrastructure.
Right. You can use the battery during peak times and when it's needed rather than building a new power plant.
Exactly, right. So a lot of infrastructure on the systems like substations or transformers, they're built to serve a specific demand requirement. And when there's increased demand in the system due to more development and so forth, when there's more demand that's being projected in the future, those substations, transformers, etc., they need to be upgraded or replaced to be able to serve that increased demand. But if you put in a battery, you're actually able to reduce the peak demand, and then you get the benefit of being able to defer some of those system upgrades.
Right. So as far as the Anza project goes, what's the business model for that particular system? How are they going to deploy it once it's built?
Right. So they have multiple use cases. I think number one is resiliency. You heard Kevin and Barry both talk about the big wildfire risks within their service territory. They had blackouts for about 10 days or so. So the battery system, the microgrid, is primarily used for resilience, being able to provide some of their critical infrastructure with backup and so forth. They're also looking to utilize their battery system for T&D deferral, deferring the upgrade of their substation. And they're also looking into utilizing the microgrid and battery for demand management.
Right. And explain the microgrid a little bit. How does the battery help them kind of get to that point where they can island their system?
Right. So they're starting small, smaller battery system, kind of seeing what it looks like, integrating it with their existing resources like their solar facility, their generators and so forth. And they're focusing their battery and their microgrid on really their critical load. So their emergency response, their schools, et cetera.
Yeah. As far as the G&T goes, we talked to Barry about how they kind of came into this project. But as a broader kind of idea of how the G&T can work with their distribution co-op in bringing these new technologies on board, tell us about how you see that developing.
Yeah, so again, we're really just scratching the surface here, and I think as more experience is gained, prices come down. I think G&Ts are going to be more and more involved with battery storage. But G&Ts today have been playing a pretty active role with battery storage. We have a couple of G&Ts that are looking at it for replacing some of their baseload generation. We have Western Farmers that just announced a really big project with 250 megawatts of storage paired with 300 megawatts of solar, another 300 megawatts of wind. So really trying to firm up that renewable resource and blend it into their power supply.
And the resiliency concerns of cooperatives, would you say that puts them in a position where they're leaders on this? I mean, they tend to have these territories where the resiliency would most benefit from on-site generation like this.
Absolutely. So the projects that we've seen to date, specifically on microgrids and specifically the use case of resiliency, have occurred in areas where there's significant risk of natural disasters. So Anza Electric Cooperative is a perfect example with the wildfire risk. We've also got a microgrid that was built out in North Carolina on the coast to help provide resiliency for hurricane season.
Right. We're talking now about generations, grade or level storage, but there are big gains being made on the behind-the-meter side. Talk about how co-ops are seeing that influence their decisions on their grid and where you see it going.
Right. So the behind-the-meter market is really fast growing. If you look at the predictions over the next 5 years or so, about half of all the capacity in battery deployments is going to go behind the meter. And that's in two specific areas. The first is in the C&I space, so your commercial industrial customers. You're talking about manufacturing facilities, your Walmarts of the world, and so forth. They're becoming increasingly sophisticated when it comes to managing their energy use. They are looking at battery storage for backup power, but also for demand management. On the residential side, a lot of homeowners who are looking at solar, for instance, they're also asking their vendors for batteries, so pairing solar with batteries. A number of homeowners are worried about losing power, so they're looking at batteries for that as well. And in certain states and certain areas of the country, there are incentives, rate structures that really incentivize the use of home batteries. And I think when you look at the behind-the-meter market, the important thing for co-ops to consider as this market develops is how do they get involved to create the most value, the most benefit for both the co-op and the C&I member or the homeowner. So can a co-op partner with a C&I member on deploying a battery storage unit for mutual benefit? Can a co-op really become that trusted energy advisor on providing information on battery storage to their members?
Right. In an ideal world, how do they aggregate that load at the residential level where they can actually deploy it, reimburse the consumer member, and use that energy for their own purposes? Is that correct?
Absolutely. And that's something that NRECA, we're working directly with a number of different co-ops that are experimenting with behind-the-meter storage facilities at residential locations, trying to kick the tires on if the co-op can actually control those batteries and aggregate all those batteries at the residential level and provide some demand response and cost reductions for the entire system.
Yeah. So as far as your crystal ball goes, we're making great gains. What's going to be the big thing that gets us to the next level with storage, where it's everywhere, where it's integrated in every grid?
So I'd say in the near to medium term, I think cost is going to be the big issue. Lithium-ion systems are likely to see continued cost declines, probably not as fast as in the past. We've seen about 85% cost declines since 2010. Cost declines are going to continue at a slower rate. I have trouble envisioning a scenario where a technology overtakes lithium-ion in the next 5 years. There is just so much money and manufacturing capacity going into lithium-ion systems that it's going to be very difficult for any other technologies to compete. Going into the future, it's going to be very interesting to see how various states that have very aggressive renewable portfolio standards deal with the intermittency of renewable energy. So as we have more renewables onto the grid, the question is going to be, how do we deploy long-duration energy storage? So I'm talking about not just a few hours, but a few days. How is that going to be integrated into the grid?
Talk a little bit about some of the stuff that NRECA is doing. I know we worked with Anza on their project. You mentioned some other larger projects. How are we involving ourselves and helping our co-ops kind of lift all boats?
Right. So we're working directly with a handful of co-ops that are deploying projects. And what we're doing is not only providing technical assistance to those co-ops, but also gathering the lessons learned and creating toolkits, guidance documents, and reports so that other co-ops can learn from these co-ops that are doing the pilot project.
We're also working with the national laboratories as well, who have research projects and very deep and broad interest in this subject. Talk a little about those partnerships.
Absolutely. So we try to leverage all the outside stakeholder partnerships that we can with this Anza project. For instance, we partnered with Sandia National Labs in New Mexico. They came into the project and helped us develop the RFP for the microgrid controller as well as the battery project. This is still a new technology, and we're still at the learning phases. So having that outside expertise from Sandia, bringing in expertise on how to develop a microgrid controller and what the specifications are is really crucial. And we're taking that information and we're creating a guidance document to help co-ops who want to issue an RFP on microgrid controller.
Right. Well, this is really exciting. I think this is going to be something we come back to regularly. I see this being a high growth topic. So thanks so much for being on the podcast, Jan, and we'll talk to you soon.
Thanks, Scott.
Thanks as well to you, our listeners, and to our sponsor, Power and Tell. Be sure to subscribe and rate us on your favorite podcast app. If you're someone who prefers to get your podcasts on YouTube with full captioning, you're in luck. The entire archive of Along Those Lines and all episodes going forward are available at youtube.com/electriccoops. Until next time, I'm Scott Hoffman.